Happy to be here. I've been playing two roles for the last few months, both serving as an associate program manager at headquarters for the Water Resources program within the Applied Sciences program, and then also serving as a scientist at Cal State University, Monterey Bay, and NASA Ames. Brad Dorn had wanted to be here today. As I said before, he was previously committed to give a talk in Beijing this week, so again, sends his best. My co-program associate is Karen Moore, who's at NASA Goddard, and of course Brad Dorn is the program manager for the Water Resources Application Area at NASA headquarters. Next slide. Just want to say a few words about the Applied Sciences program. I got it here. Looking around the room, I think most of you are very familiar with it, but did just want to say a couple words, and then I'll provide a few thoughts on what might be part of the path forward. Primary role of the NASA Applied Sciences program is to help bridge the gap between the work that goes on under the research and analysis programs within NASA that are focused on understanding the terrestrial water cycle and potential applications and uses of the NASA research results by partners and stakeholder communities. And at present, the Applied Sciences program within NASA is focused on societal benefit areas that are defined by GEOS, with an emphasis in 4 areas in particular right now. The highest level primary goals of the Applied Sciences program are to enhance applications research. And this means both identifying priority needs, conducting applied research to generate new applications, and then supporting projects, and in particular supporting the transition of projects into an operational state, finding a home for them so that they can be sustained by partner agencies. Increasing collaboration is another important focus for the Applied Sciences program. So I think one of the things that was really impressive to me about many of the talks we heard over the last 2 days was the number of partnerships that involved multiple federal agencies, multiple state agencies, collaboration between state agencies, participation and important contributions from the commercial sector, and then finally accelerating applications. So the Applied Sciences program is increasingly trying to get involved in NASA satellite missions from the various early planning stages to ensure that an applications perspective is represented in mission planning. The 4 current emphasis areas are health and air quality, disasters, ecological forecasting, and most importantly to us here today, water resources. In addition, the Applied Sciences program is always looking for opportunities to support applications that also apply to agriculture, climate, weather, energy, and our oceans. Within the Applied Sciences Water Resources program, the current projects primarily fall under these 6 categories, and they involve projects that support decision-making related to water delivery and water use, including, of course, measurement and monitoring of evapotranspiration, agricultural use, as well as crop water requirements, snowpack monitoring and water supply, water quality, flow and flood forecasting, drought, and climate and water resources. The program supports primarily national but also international activities to improve skills, share data and applications, and broaden the range of users who can apply satellite data and earth science information in water resource decision-making. The Applied Sciences primarily focuses on applications, applied science, and application development. We also work with the capacity building program within NASA, and this sponsors specific activities to build skills within user communities and provide support for development of new capabilities in the U.S. and developing countries to ensure accelerated use of remote sensing data. And so this includes things like the SERVIR program, the DEVELOP program for students, Gulf of Mexico initiative, as well as the development of training modules and supportive workshops like this. But there is funding available through this program to support additional hands-on training and workshops. So the Applied Sciences programs primarily fund solicitation for demonstration of applications and realization of socioeconomic benefits, as well as transition of applications to partner agencies and organizations. And the capacity building programs provide support for new opportunities for new users and organizations to become increasingly aware of Earth science, what satellite remote sensing offers for decision making, and increase their capacity to make use of those observations. NASA currently is supporting, I think about 16 missions now that are in operation. Many of these can be used to contribute to our understanding of the water cycle. And all of these highlighted in yellow contribute to understanding of the terrestrial water cycle. And so we've been focusing heavily on Landsat and MODIS, which really are the workhorses for terrestrial remote sensing. But there are a number of other missions that the Applied Sciences program works with to develop applications related to water resources monitoring and management. A couple of missions that were launched last year. The Aquarius, this is really focused on ocean salinity. And then the NPOS preparatory mission, now known as the SWAMI mission. This is part of the transition from the Terra and Aqua and POS satellites to the JPSS, Joint Polar Satellite System. So this was a prototype mission. This carries on at VIIRS, which is the next generation of MODIS. The resolution gets a little bit better for some of the bands, down to about 750 meters. Unfortunately, for the red and near-infrared bands, the resolution is now a little coarser than on MODIS, 375 meters. LDCM, of course, we've talked quite a bit about. A few other upcoming missions. ICESat in 2016 will provide observations to support improved understanding of the cryosphere and changes in ice dynamics. SMAP is another important one, the Soil Moisture Active and Passive Mission. GPM, the Global Precipitation Measurement Mission, and then OCO, less relevant for water management, but important for understanding carbon fluxes. I think we've covered Landsat extensively. I won't say anything else about it other than to say that I certainly hope to be there at Vandenberg in February with my fingers crossed and toes crossed and hoping for all the best with that launch. Really looking forward to it. I do also want to highlight the Soil Moisture Active and Passive Mission, which is coming up here for launch, hopefully in, make sure I got this right, in 2014. It will provide a capability for global mapping of soil moisture at a 10-kilometer resolution with a 2 to 3 day revisit. I think we've heard a number of conversations, not just about mapping at field scale, mapping of ET at field scale, but also using ET information to improve estimates of groundwater fluxes and try to look at regional water budgets. So I think the combined use of ET, in addition to observations of soil moisture, can further help to constrain hydrologic models to look at key fluxes in basins. I think two of the most important science objectives related to what we've been talking about are this estimation of global water and energy fluxes at the land surface, as well as understanding processes that link the terrestrial water, energy, and carbon cycles here. The Applied Sciences program provides funding primarily through competitive solicitations. This was the most recent solicitation that was issued in 2011. Projects just got started this year. This last call was focused on drought. We did hear from Martha Anderson at USDA about this work here. It's being led by Chris Hain at NOAA and the University of Maryland on the development of the Evaporative Stress Index. It's also supporting a lot of work related to mapping and monitoring of snow water equivalent and snow water resources, Jim Verdon's work on mapping of fallout areas, and our work at NASA Ames on developing products to support the agricultural community in developing efficient irrigation strategies. So with that, a few thoughts, and these are just my thoughts on aspects of the way forward. I think first and foremost, it's important to step back and say congratulations to this community. When we look at, Bill talked about the fact that some of this work was started with a NASA Applied Sciences grant back in 2003, and when we look at what's been accomplished, both the diversity of uses, the number of uses, and the continuing and ongoing tech transfer between different users in different states, I think it's something that everyone should be extremely proud of, and the work that's been done to advocate for continuing satellite Earth observation missions is outstanding. A few thoughts in advocating for satellite missions. I think it's easy to continually refer to Landsat, and that's important because it's difficult to say, well, what we'd really like is a capability that has a spatial resolution of 30 to 100 meters with a thermal band, visible bands, near-infrared, shortwave infrared. That's a mouthful. So Landsat is a convenient bucket to put all of that into. But in communicating that information, I think it's important to also specify the requirements for use and the value of ET information for water management. And by specifying requirements and value, I think it will provide NASA, which is a research and development agency, it will provide NASA with a little bit more flexibility in working with USGS to come up with long-term solutions, especially looking beyond Landsat 9. So I think that's an important point that shouldn't be overlooked. I think it will be important to broaden the user base of ET information. So I think Justin at one point used the term ET police, and I think that could create some risk for Landsat being perceived as an enforcement tool within the agricultural community. And so I think it will also be important to look for win-win solutions and opportunities to increase use of satellite information, not just thermally derived ET, but also information from the other bands, by the agricultural community, and in particular by growers and grower associations. So some of the work on accelerating development of water markets, supporting irrigation management, on and on. I think those are very important examples and things that are worthy of additional support. I think it's important to increase investments in data distribution wherever we can. And we saw a number of examples of where folks are making the effort to distribute their data via web services, via some of the tools provided by Esri, via some of the open source web services and data distribution tools. I think that has to be done, especially for the science community. That's extra work. Often we're not rewarded for it or given credit for it, but it's essential to increasing use of ET. I think we also need to, this community has done a particularly good job of this, but the effort has got to be sustained. We must continue to build on partnerships to accelerate technology transfer between states and agencies. So building on the lessons learned in Idaho, trying to bring some of those lessons to other states, and that's certainly ongoing. I'm really excited about the partnerships now between Justin's work at DRI and some of our ongoing collaborations with the California Department of Water Resources. Very much looking forward to seeing where that goes. I also see a need for additional coordinated model intercomparisons and verification and validation campaigns. The work that USGS and Utah State is doing is an important first step. We may, depending on how that goes, may need to supplement it with additional campaigns. And I think the question of what surface observations do we use was raised a couple of times. So I see a need for compilation and review of the available surface measurements of ET so we can provide a reference data set for folks developing and testing either new models or improvements on existing models so we can quantify, for example, quantify any the accuracy associated with automated models, quantify the accuracy associated with new models that are developed. I think that'll be an important resource. And finally, development of standards for use of different satellite-derived ET models. And we heard both from the USGS Utah State effort as well as Rick mentioned the ACSC. So those are very important efforts to support with